It is time to revisit the security debate between the X86 Wintel and the IBM zOS mainframe platform. The reason is that the Z14 IBM zOS will entail pervasive encryption by Paul, Renda, and
Nick Benigno.
Okay. And if you're just interested in that picture there, that was from an article in 1995 from the New York Times of the 2600 used to have, or they still have meetings in the Citicorp Center in the once every first Friday of every month. And the person sitting down giving the talk is me. So I've been around a very long time. And I asked to be photographed in silhouette, but you can see my jaw and my glasses. Okay. Today, data breaches are inevitable. However, if the data is encrypted, it is of no value to hackers. Paradigm shifts in information technology. In the early 1960s, the IBM 360 computer changed information technology in that it was upwardly and downwardly compatible with software written. The personal computer by IBM was another paradigm shift. Apple computer, another paradigm shift. Gates and Jobs visit Xerox Palo Alto, and it's the birth of the graphical user interface. They realized that having a GUI made computers and personal computers very useful, that there's no longer, you have to use online commands. And again, the Xerox management did not realize it. They did not discover it or understand it. Gates and Jobs, they had the prepared mind so they could evaluate and understand the importance of it. Next paradigm shift is the IBM Z14, the system enabling pervasive encryption. And again, it enables pervasive encryption, but you do have to build rules to enable it. It does not come, the encryption is not automatic when you turn on the box. The next major paradigm shift, and this is important, is quantum computing. And unfortunately, it looks like the Chinese are ahead of us with that. The history of the IBM mainframe 360 computer. The IBM mainframe came of age in the 1960s. This was a time when corporations were migrating from pencil and paper spreadsheets and accounting ledgers to computers. This was a major revolution because at that time, people had very little experience with computers. The problem with computers is there was nothing tangible to feel or see. Corporate financial records were consigned to bits and bytes on a computer. Again, this was a time when people had very little understanding of computers and what happens if somebody massages or manipulates the data on the computers. And that also spawned the creation of EDP auditors. Really a group that sort of fell into, I think, hard times. History of the X86 computer. Intel's 8086 was a start. It was extremely successful. It was sort of having a microprocessor for everybody. The evolution of 80, 186, 286, 386, 486. Again, the X86 was a general purpose microprocessor, and it was probably the most popular and the most successful, more successful than Motorola's microprocessor. Ultimately, they migrated to the i3, i5, i7, and i9, keeping most of the X86 legacy. And again, it's basically the cheap microprocessor to use in blade servers. And if you want to just increase massive computer power, you just keep adding on and adding on. Third-party breaches. Third-party breaches remain a dominant security challenge for organizations, with over 63% of the breaches linked to a third party. And again, this is people dialing in or going through the internet onto your server, your mainframe. They're a major problem because you do need to have access parties to have access. It could be an insurance company, a bank, a pension fund. But again, you're talking to everybody else. And their major problem, and probably the biggest problem that I see. And since I'm administrator of a large mainframe site, I see this as a significant issue. No matter how good you have your security on your site, when you allow people in, you can have problems. Okay, this is something I have to talk about a bit. The ZIOS operating system and DEFCON and Black Hat. A number of years ago, they had somebody by the name of his computer, I think it was Fortran, and he took a DEFCON and Black Hat. And he had access to a mainframe computer that was not kept up. In other words, it was not updated with new security fixtures. It did not look like the people who, RACF was a security package, it's an IBM security package. It was not, again, kept up to standards. And again, if you have any type of security, either X86 machine, whatever Unix or Linux machine, or whatever IBM, if you don't maintain the security levels, if you don't maintain any type of fixes to the operating system, it's going to have all sorts of problems. And this machine that he did demonstrate had a tremendous number of problems. And a number of the problems, which one problem in particular, it said that if you use the SU command on this machine to become a super user. In other words, on the Unix or Linux side, you could become a UID of 0, which is the super user. Well, if you have a Linux or Unix box out on the internet, and you don't have the setu command or the command to become a super user protected, it's not going to last long. And the DEFCON or Black Hat people, either they were not that technically sophisticated to realize there was something wrong here, or they're just enthralled about an IBM mainframe having problems. I don't know what it was, but it was very deceptive. By the way, I did know about this talk ahead of time, and since I spoke at DEFCON a number of times, I asked, can I be on stage with them, commenting on the security exposures? And DEFCON said no. Again, if you go to any security conference, including DEFCON or Black Hat, you do have to take everything with a little grain of salt. You have to do some checking up on it. Okay. Let's just talk about the trademarks. IBM, the RACF is a security product called RACF Access Security Function, RACF Resource Access Security Function. It's an old thing that has been updated many times. I think it was first created in the late 1970s. CA7 and Top Secret also security products. Computer Associates owns them. Unix, I believe, is owned as a trademark from the Open Group in the United States. Microsoft Windows, Windows NT, trademarks of Microsoft Corporation in the United States. Okay, the Rainbow series. In the late 70s, the Defense Department created the Rainbow series. And it was really a series of books to create security on computers systems. The orange book has A to D ratings. The green book, password management. Light ping, covert channel analysis. Aqua book, glossary of security terms. Brown book, trusted facility management. The only book that I see referenced today, and people will say it's obsolete, is the orange book. And I will go into some interesting aspects of the orange book. The orange book has security classifications from D to A. D is minimal production, reserved for systems that fail evaluation. C1, discretionary access controls. But you don't need to distinguish between individual users and types of access. C2, controlled access protection. The system distinguishes between individual users, types of access, gives object reviews, and the features required. Okay, the B1 is where you see a demarcation line in production. It is mandatory access control. Basically, you have security labels required for all subjects and storage objects. B2 is a structured protection. Again, mandatory access controls, sensitivity labels required for all subjects and objects, trusted path requirements. B3, again, security domains, again, mandatory access controls, access control lists, specifically required. In other words, you do not have an object out there, let's say a data set out there that has no access control list. Everything needs to be required. And the system must protect against covert channels. A1 is verified design, again, mandatory access, formal top-level specifications required, configuration management procedures must be enforced throughout the entire system lifecycle. In other words, you have a security group that enforces it, and you may also have a QA security group that validates it, either a QA security group or an audit group that validates it. Maybe not at the real-time level, but definitely within a week's time or less. A1, self-protection and reference monitoring are implemented. Trusted computing base, TCP verified to source code level. Now we have an interesting matrix. We have discretionary access control. Again, the D1 level is not, the D level is not in this matrix because everything at D fails, so doesn't have matrix. Discretionary access control, again, it goes from C1 to A1. Controlled access, where you have access lists which identifies the user, again, C2 to A1. Mandatory access control, again, it's B1 through to A1. And there are a number of other labels, other requirements that as you go down the list, the B1, B2, B3, or the A1 have to fulfill. Let's talk about discretionary access controls versus mandatory access controls. I have a little text here, but somebody can work in the payroll department. They can copy over the file with discretionary access controls and send it to any of their friends working in accounts payable or other systems. So basically, it's at the discretion of the person who has access to that object. Under mandatory access controls, you have a type of token or security level or something on the file that identifies that it's under mandatory access controls. And the people who can see it are the only ones who have that same type of token or security level on their ID to see it. So if you copy over a payroll file that's under mandatory access controls and try to send it to somebody who's outside of payroll, they would not see it because they would have this type of token or security level on it. So they'd be impossible to see. How do you break these access controls, mandatory access controls? Simple. You hook up instead of having a dumb terminal, you have a smart terminal, some type of X86 box or any type of box running that is smart. You could display the payroll file, which has, even though it has a token on the mainframe, you could do a text file, you cut and paste it in your email and send it to everybody else, every man, woman, and child in the free world. So that's how you get around mandatory access controls. Again, when I talk about mandatory, I'm talking about only at the B1 level. Okay, the next one. The next security controls, again, some people say obsolete, well, evaluation assurance level, EAL. Again, I have the link down there. It's quite impressive. Let's go again, next slide. Okay, these are the evaluation assurance levels. And a little dry mouth. Do you want to just read them off, Nick?
Sure, yeah. Evaluation assurance level. So EAL1, that's going to be fully tested. EAL2 is structurally tested. EAL3, methodically tested and checked. EAL4 is going to be methodically designed, tested, and reviewed. EAL5, assembly formally designed and tested. EAL6, assembly formally verified, designed, and tested. And EAL7 is formally verified, designed, and tested.
Well, don't change channel yet. Let me go back in. A lot of the security, like SANS and other groups that give security tests, most of the time you will not hear anything about the Orange Book or the EAL levels. And you would not know what systems are at those levels or what systems are not at those levels. So again, this is going to fill in some information for people who maybe they have a CISSP or other level, and give them a feeling for evaluations at the different levels. Okay, next slide. This is basically, in my opinion, it's incorrect. Tries to give the equivalency between the Orange Book, the European IT SEC levels, and the common criteria levels. Again, the B1 is where you have mandatory access controls, and an EAL4 is not a mandatory access control. I'm not sure who set this up, but you should be aware that you cannot directly correlate one to the other. Although as you go down the line from EAL1 to 7, the security controls increase. As you go from D to A1, the security controls increase. The European thing, EAL0 to EA6, I haven't seen many people use that. I'm not that familiar with them, but it does exist. And again, let me talk about some more about the EAL levels. Next slide. These show the assurance class of what you need to have for each of the EAL levels from 1 to 7. And as you start to get to EAL7, it has all of these development guidance documents, life cycle support, and which really should be developmental life cycle support, security target evaluation, tests, and then vulnerability assessment. You know, so obviously it's beyond the scope of what we're going to do here, but these show levels, assurance family, and these show the necessary conditions for these different levels to have. And this is pretty much inclusive. Go to the next slide. These show certified product by assurance level and certification date. If you go down the slides from EAL1 to 7, you're going to find that there are very few and fewer at the EAL6 and 7 levels. They're more costly to do because need more evaluation. Again, it gives you a breadth of understanding of how difficult it is and how much you have to do in testing to evaluate these levels. So this should give you an appreciation that these levels do mean something. Again, some people say they're obsolete. I see people using EAL levels and the Orange Book levels all the time. I don't really see too much else. Next. EAL by device. The Internet of Things, I have an EAL1 to 3. I put the 3 in there. I should not have put the 3 in there. I've seen Internet of Things devices have EAL1 or 2, or no EAL level at all. In other words, people, the Internet of Things, you're putting these gadgets on your network to provide some type of function. And to give you an example, they could be Arduino, which is a microprocessor. It could be Raspberry Pi. Again, these are not things that you need licenses to. You just buy the product for very little money and you can go up and running. But again, Arduino has, as far as I know, no EAL level at all. Raspberry Pi, there was this computer science student for his master's thesis who did evaluate Raspberry Pi, and he did evaluate for some criteria valid criteria, but he did not put it at an EL level of anything. Again, it was a master's student. It was a smart thing to do for a master's thesis, but I think that he should have looked at some type of an EL level or Orange Book level. And again, it was good. Again, Raspberry Pi has many holes in it if you're going to put it on your Internet of Things or your network. EAL4 is Windows, Sun, Linux, Red Hat. EAL4 is really the first level where you do have security, that you've identified users, you have an access control list, and where you're really putting some type of security interface in there that you could allow people or your employees to use. EAL5, IBM LPARs are EAL5, and basically it almost means you're air-gapped. That is, between the logical partitions in an IBM system, they're air-gapped. If I want to get to one LPAR to another, I have to write specific security rules to do that. And also using TCP/IP. It's almost as if you have two separate computers. Logical partitions, an IBM machine, you could create logical partitions. In other words, if you're not really familiar with that, you think of VMware, where you can run logical machines under the same CPU. Again, under an X86 machine running VMware, I'm not sure what the EAL level between the machines is. If you have a multi-core advanced micro devices or Intel device, I'm not sure what the levels are, whether or not you can get to the other levels. I think I read somewhere that you can get to the other levels. I don't think it's by design. Again, it's somebody who wrote a master's thesis or maybe a PhD thesis on it. EAL6, that's when we get really serious about things. And you want something that can operate, cannot be spoofed or interfered with. Aviation operating systems tend to have that. Again, fly-by-wire for the F2, F-16, F-35, the Airbus. Again, if you're flying in a fly-by-wire machine running with this operating, you want it highly secure. EAL7 is very hard level to get at. Again, if you look back at the slide before, very few systems are evaluated at an EAL level. A smart card was evaluated, I think it was a Samsung smart card that was evaluated at an EAL7 level. Again, the smart card is like a challenge card, and you can do a Google search on this and look at it. Okay, next slide. Okay, this is the reference for Windows at an EAL4 level, so you could look that up. This is the reference for IBM LPAR at an EAL5 level. Again, you can look that one up too. Okay, now we gotta go digressing on a little something different. 1 second. Since I'm talking, I do get a little dry mouth. There are two internal configurations of the most popular computers, IBM mainframe and everything else. IBM mainframe is called EBCDIC. That's the internal configuration of what the data looks like. EBCDIC on IBM mainframe, it's not case sensitive. Paul in caps does not equal Paul in small letters. ASCII 2 is Windows, Linux, Unix. Everything else under the sun, I think, has ASCII 2. It's case sensitive. Paul is not equal to Paul in small letters. And IBM mainframe ZOS Unix side uses that. Next slide. The IBM ZOS mainframe has two sides, a traditional EBCDIC side and an open Unix side, which uses ASCII 2. In other words, on this open Unix side, you can easily just transfer files from an X86 server to the Unix side, and then ASCII, they be converted or anything else. Next slide. Now here again, we're going to digress a little bit about encryption, symmetrical versus asymmetrical. In symmetrical, the key to encrypt is the same key to decrypt. It's not really very useful for commerce. It's like a one-time pad in a sense. You have to transmit the key. PGP, pretty good encryption. That was created about 1991 by a guy named Zimmerman. And I think the Defense Department took exception to that because they considered encryption basically a type of weaponization. In other words, they couldn't read it. An interesting thing is that IBM mainframes going back to, I believe, 1976 did have encryption of the passwords. And I think they used 56 bits, not 64 bits. And everybody thought the reason why they used 56 bits was because of the NSA wanted to be able to decrypt them. So anyway, we get from our time in the late 70s of 56 bits. Today, when I create an encryption key, I only use 4K keys, which is the highest that I can use at this level. So, you know, we've been going up. Some old websites may only use 128-bit encryption that have not really been maintained. Asymmetrical encryption, the key to encrypt is different from the key to decrypt. It's called public key, private key. RSA is the most famous version of that, and it's most widely used. It's the X509 not evaluation level, it's the standard really. The problem potentially is quantum computing. And again, our big problem is China. China is a problem because it's potentially available that if you mass a quantum computer, you can break these 4K keys or these 2K RSA keys readily. China's another problem because they did create a desktop operating system that is sort of Linux-based. And they said they're grading that at the B2 level. In other words, they're using the Orange book, the Defense Department book, and they're grading at the B2 level, which means that mandatory access controls and both on whatever they're using as a server and on the desktop. So that's a big issue. And in the West, we haven't really looked at China, or they're saying that it's a B2 level. RSA, again, the most popular encryption level. I use it. That's really the only one that I really use on the mainframe or even on the X86 machine. It's an asymmetrical encryption method, the private key, and it has a public key. Again, it's most easily used encryption methodology for business transactions. If we didn't have this public key, private key, we would not have this just massive amounts of commerce on the internet. Do the FIPS.
Okay, so Federal Information Processing Standard 140-2. It specifies the security requirements for cryptographic modules, and it was created by NIST and the Department of Commerce. It's used by CMVP along with other standards. According to FIPS, cryptographic modules are required to meet documentation requirements, to meet general physical security requirements, to meet cryptographic key requirements, be able to perform self-tests like power-up test or cryptographic test, to use the finite state model. FIPS divides security requirements into 4 levels. Here are the 4 levels in a nutshell. Level 1 meets the basic security requirements mentioned earlier, and it's the most cost-effective level. Level 2 adds physical security requirements. These include locks, tamper-evident coding, and seals. It adds role-based authentication. Level 3 is when you probably see the biggest changes. It adds tamper detection and tamper response, and it responds with zeroization. It adds identity-based authentication. The I/O of manual methods must be in encrypted form, or it has to use split knowledge procedures. Level 4 adds enhanceability to detect to physical access. There's more of like an encapsulation around the module, and also with level 4, it's able to detect changes in voltages and temperature.
Don't change the channel yet. Let me just get over. At level 3, which says I/O manual methods must be encrypted form or use split knowledge procedures. Split knowledge procedures I interpret as a separation of function, which again, separation of function is very important. On the mainframe level, we still have separation of function. The computer operators may not be the ones doing the backups at night. And again, the people running the machines may not write the security rules. You have separation of function. You don't find that level of separation of function on the x86 machines. You sort of have the same person, at least doing the updates and the backups. And again, it's level of separation of function. It's something old-fashioned, but a lot of people would not be aware of that. Now we're talking about the IBM cryptographic coprocessor. And also, if you look at it, you realize it's a half-width PCIe cryptographic card, which means that it could fit into an x86 box because it is using a PCIe card. I doubt that IBM would sell it to people, and then you would need the drivers and probably I'm not sure what the internal configuration is, whether it uses EBCDIC or ASCII. But the cryptographic card performs symmetric hashing, AES, DES, TDES, SHA-1, SHA-2. Recently, in the past 2 years, we had the great upgrading from SHA-1 to SHA-2 because the SHA-1 had security issues. There's asymmetric algorithms RSA up to 496. Again, it's 4K, which is what I use exclusively 4K. I don't use 1K. Rarely do I use 2K. Mostly I use 4K. The important point, it's FIPS 104-2 at level 4. It's at the highest level, and the FIPS was created by, I believe, our Commerce Department or the National Institute of Standards. So it's a government level for cryptographic. It's at the highest level. It's an EAL level 4, which I think is really good enough because there's physical controls and separation of function, and there are a number of other techniques not to get access to it, and it's tamper-proof. Again, suitable for high-speed cryptographic function of data encryption, digital signal processing. Without everything connected to everything, and people who've seen online commerce on the cell phones and everything else, you need a fast machine that can encrypt in real time. And again, this is what IBM has created with this. And this is also something that was demanded by a coalition of, I think, banks and other companies, a coalition of almost 150 end users who asked IBM for this. And they did create it for the Z14. Right now, I only know one bank that's actually advertising it, using it. It's the Mellon Bank. And I would think having pervasive encryption is a type of marketing ploy too, that a bank or insurance company or financial service company can say, you know, we try to protect your data is encrypted in our machines. And again, security is an ongoing process. It's not a stagnant process. So encrypting data just adds you another level of security. It's not the end all, but it is something. Okay, it's a secure device that can deal with a number of physical and logical attacks. This protection includes being able to withstand side channel attacks. And now we're going to talk about, I'm going to talk about side channel attacks. First of all, hackers have a saying that if you have physical access to a computer server, you own it. Why? Well, you could flash the BIOS, the basic input operating system of the computer. You could intercept the keyboard with a dong or keyboard in a probe that you attach to it. Do cable intercept the cable, or the cable leading to your Ethernet, or was it the hacker ring? Not the ring, the token ring. You can also get the hard drive. Again, once you have access, and everybody has access to their mainframe that's on top of the desk, you lose a little bit of security, but that's unavoidable. Side channel vulnerability. Let me differential power analysis. You could use power analysis to see what's going on in the computer system. Simple power analysis. All analysis performed during a crypto event, encrypting and de-encrypting, acoustics vulnerability. Side channel is not something you're going to learn from any type of a security conference or school that advertises, take these security courses. It's really for a hacker. And it's actually very old. The government first learned of side channel earlier on, I think in the late 40s or 50s with teletypes. Teletypes were very noisy electronically, that they had side channel vulnerabilities. And again, this had to be quashed. The IBM 360, the early one, had side channel, really more called Tempest. And it had multiple side channels. Tempest is just one of the side channel vulnerability. Tempest is intercepting the electrical functions from the computer and interpreting them. But the IBM 360 had multiple side channel vulnerabilities. Again, this is the early 360. One programmer was able to write a program that played a tune on the IBM 360. And also some could put a radio on top of it and tune it and pick up the side channel noise from it. Another side channel vulnerability is that the 360 had a lot of lights, and you could see from what lights were active, what the machine was doing. So again, these will be side channel vulnerabilities that have been solved. Actually, another vulnerability that I should have mentioned about at the DEFCON or Black Hat was a vulnerability that the IBM mainframe has right now is, or used to have, is that if a programmer, and usually a system programmer, had access to an authorized program facility library. This is a library that runs in the kernel or the nucleus of the operating system. He could actually change the security profile. In other words, he could become a, in the Unix version, a super user, a UID of 0, or he could become a, under RecF, system-wide special or system-wide operations. So he could achieve these tremendous powers. And IBM has dealt with this vulnerability. Again, it's up to your RecF people or you people using a top secret or CA7 to correct this. It's not something that's corrected by default. You don't plug the machine in and it has that protection. Okay, let's go again. Famous side channel attack, and there have been many of them. The Soviet Union had an underground cable that went under the ocean floor. And a specially outfitted US submarine was able to put a device on top of the cable and was able to read messages in real time. Again, it did not need to break into the cable or anything else. Just by laying on top of the cable, it was able to pick up these electronic vibrations and interpret what was happening. And again, the Soviet Union had no idea what was happening. I think the only reason they found out is they needed to do some type of upgrade in the cable, and they found this gadget attached to their cable underneath. Again, it's side channel is a hacker's hack. You have to be a hacker's hacker to know about side channel and the vulnerabilities. This shows it's from Renda Security Division. It's Introduction to Differential Power Analysis. Again, it's used for side channel. And again, there's reference there, Renda Security Division. You can click on the internet and learn more about side channel. Next slide. No, not this. Let me just take a drink of water. Successful side channel attack against RSA. And a coup attack against RSA by one of its creators, Shamir, from RSA. And it shows the integrity, the competence of this guy to actually try to find a security flaw against RSA. And it's only on desktop X86 machines and laptop X86 machines. And he was able to extract a 4K key from the machines. He was able to use a mobile phone placed by a laptop. He was also able to use a more sophisticated, sensitive cable, sensitive microphone. There's a whole paper written by him and two other co-authors. Shamir does, I looked into his background, he just has a math cryptography background. To develop this type of attack, the person would have to know something about electrical engineering and noise analysis, or to extract signals from a noise. And again, that's more like a person with a bachelor's degree in digital signal processing, or master's degree, digital signal processing, electrical engineering. Again, it's a hacker's hacker. So it's very interesting. Again, how about optical cable? Is that a possible side channel? I don't know. Change the channel. Okay. So these are the conclusions. IBM Z14 is a major paradigm shift in computer technology due to its ability to have pervasive encryption. Companies that do have a mainframe can use the Unix ASCII to the side of the mainframe to back up important documents in encrypted format. Also, they could use the side as a backup engine. One thing that came to my attention when New York City, particularly downtown, the financial area had Hurricane Sandy. The companies, and these are financial services companies, one company in particular, and I was never able to find out the exact name of the company. Their X86 system, their service system, they had trouble backing up because the backup procedures and the backup information was not at the level that they could easily come back online, whereas the mainframes had a much better historical backup capabilities, and they also had a lot of offsite capabilities. So it was easier to back up the mainframe systems than the X86, their server system. If you have a server form of 100 servers or 200, you got to keep an eye on, let's say, 200 servers. If you have an IBM mainframe which has maybe 10 LPARs, it's easier to keep an eye on 10 LPARs than 100, 200 servers. Again, the IBM logical partition has an EL certification of 5. The IBM encryption card meets FIPS 104-2 level 4 secure hardware encryption, and it's tested for side channel vulnerabilities. So that's the end of the discussion. And if you have any questions, my email ID is prenda, P-R-E-N-D-A @pipeline. That's PIPELINE.com. If you have any questions, or if you know of IBM vulnerabilities that you think the public doesn't know about, you'll send it. In the subject area, you have to put IBM mainframe vulnerabilities or IBM mainframe questions, because of a spam filter that's going to catch it. So I'd have to see it when it hits my spam filter. But again, my name's Paul Renda. I've spoken at a number of conferences. Also, that earlier picture you saw was from 1995 when I was teaching at the 2600 monthly meeting. Now you have monthly meetings for DEFCON 2600 around the world. So you can go to any of those meetings. And again, I was teaching there. That was 1995. So I've been around a long time and I've seen a lot of things. And again, it's Renda, P-R-E-N-D-A dot pipeline, P-I-P-E-L-I-N-E.com. And I'm interested to hear if you have any comments. So, get back to me. Nick, you want to give them your, if you don't mind giving it out?
Well, sure. Yeah, my email is n.benigno, B-E-N-I-G-N-O 12 at gmail.com.
And tell them that you're a student and you're graduating this year.
Right. I'm a student at UAlbany, and I'm a senior right now, and I plan to graduate this year.
And you're majoring in?
Oh, I'm majoring in informatics and with a concentration in cybersecurity, and I minor in emerging preparedness, homeland security, and cybersecurity.
And I hired Nick as a research assistant to research certain things. Okay, so thank you very much. This is the end of the talk, and